afternoon. My name is James Simpson, and as you know, I'm an MSc Computer Science student at UCL. And today I'll be presenting my project, GenAI and Data Dynamic Supply Chain Scenario Modeling. This work was carried out in collaboration with Alvarez and Marcel. Context and motivation. Trade policy shifts are unpredictable, and in sectors like automotive, where they can have a big impact, where margins can be quite slim, this creates demand for rapid scenario modeling. At the same time, breakthroughs in generative AI, particularly large language models and multi-agent frameworks, make it possible to model complex human workflows. The motivation here was to test whether this technology could perform at a level of a junior analyst and free up time for consultants to focus on higher value client-facing work. Problem statement. The core challenge is straightforward. Can a multi-agent AI system replicate the role of a junior analyst? This means combining speed and automation with outputs that are reliable enough to be useful in a professional setting. The reality for consultants is that junior analysts can often spend hours preparing data, building models, and drafting reports, sometimes late into the evenings. LLMs on their own show promise, but they're weak at multi-step, domain-specific analysis. This is where multi-agent workflows come in. Scope of the project. The system I built brings together several specialized agents. A data agent for analyzing bill of materials, CSVs, a tariff simulation agent to model different tariff shock scenarios, a web research agent for gathering recent tariff news, in addition to a deep research agent for identifying alternative suppliers. These were connected into a structured multi-agent workflow that mirrors the tasks a human analyst would typically perform. Requirements. The system had to meet a list of functional requirements. These include ingesting structured data, running tariff simulations, conducting web research, generating charts, and producing professional reports in PDF or Word format. Also defined are a set of non-functional requirements, things like running within an hour, being usable on a standard laptop, and providing interim feedback to the user. Together, these requirements ensure the system wasn't just a proof of concept, but something that could be realistically deployed. System architecture. Here's a higher level overview. At the start, the planner agent decomposes a task and creates a structured plan for the system. The data agent analyzes the CSV inputs, extracts the required data, and then this data is fed into the chart planning and codata agent, which generate visualizations using matplotlib, and then moves on to the research agent, which looks up tariff news on the importing country and automotive sector, while the deep researcher finds alternative suppliers. The simulation agent runs the tariff shock scenarios specified by the user, and finally, the report writer agent synthesizes everything into a structured report, and a reflection loop refines the report through critique and revision. Subgraphs. To improve maintainability, parts of the system were separated into subgraphs. Here we can see the data and simulation agents both had React style loops, whereas the codata agent here had a generate, execute, reflect loop. In the event of an error, the reflector node would prompt the generate to try again, displaying the previous error, or where, on the other hand, if the execution went fine, it would proceed directly to the generate node to produce the following graph, skipping reflection. The report writer had a write, reflect, research loop where the reflect agent critiques the report, looking for things like missing sections or graphs, and then the research critique then uses this feedback to search the intent for additional research material, and then the writer regenerates the report using the feedback from the reflect nodes, in addition to the further research materials from the research critic. I've named my system Supply IQ. To benchmark the system, I compared it against a traditional human analyst workflow. Whereas a human analyst takes hours and costs significantly more, the multi-agent system runs in under 15 minutes and at a cost of less than 30 cents per run. Findings and future. Feasibility. It's possible to build a deterministic multi-agent system that handles tariff simulation, data analysis, and research, performing at the level of a junior analyst. Limitations. A notable limitation of LLM systems was observed during my testing is that they can hallucinate when encountering corrupt or incomplete data, underscoring the need for human verification. Future potential. Looking ahead, scaling laws suggest that LLMs could plausibly achieve top human level performance. This more speculative frontier is whether they can, the more speculative frontier is whether they can surpass it. Unlike narrow systems such as AlphaGo, which benefit from a clear reward functions, language models operate in domains without such structures, making it possibility of superhuman capabilities less certain. Overall, the project showed both the immediate value and long-term promise of applying multi-agent GenAI to consulting workflows. Thank you for listening. Welcome to the Supplier IQ report configuration page. So first I'm going to input my brand and model. In this case, I'm going to go with the Toyota RAV4. I'll then come up with the engine options. So I select the engine option that's appropriate, and then I choose my parts category. So I can do the complete vehicle, or in this particular case, I'm going to choose a component, which is going to be the braking system. Next, I need to input my manufacturing location, so the United Kingdom and the VAT rate. After I've done this, I then need to choose my target country for the tariff shock simulation. So I'm going to put Japan too. I'll tell you why I spelled it wrong later. I then need to put in the tariff shock rates. So I'm going to put a moderate, high, and a worst case scenario in. And I need to upload the parts data. So this is the brake disc, brake pads, etc. And the articles data, which are the different suppliers for each of these parts. And then click configure tariff rates and generate report. As you can see, Japan 2 was not found in the article, so I need to adjust that, remove the 2. So I've just deleted that, the 2 at the end, and it should now work. Yes, it works perfectly. Now I put in the tariff rates. I'm putting in the base rate according to the World Bank WITS for the United Kingdom and auto parts. So putting that in and then putting 0 for the United Kingdom. As you can see, the generate report option comes up. Clicking that, as you can see, report is being generated. It'll take approximately 20 minutes, and I need to look at the terminal console to monitor progress. Today I will present the output of my multi-agent supply chain system. The case study focuses on the Toyota RAV4 braking system manufactured in the UK with tariff shocks applied to imports from Japan. The aim is to assess the cost impacts under moderate, high and worst case scenarios. Executive summary. An executive summary outlines the study scope, key cost drivers and initial assessment of tariff impacts on resilience. Component analysis. This section breaks down the braking system into parts, highlighting cost contributions, origins and supplier concentration. 3 visuals show article counts and prices, country of origin distribution, and a tabular parts summary. Tariff simulation. Tariff shocks are modelled on Japanese imports with costs recalculated including VAT. Results are shown through cost progression and distribution charts. The recalculation of bottom quartile suppliers in each scenario reflects procurement dynamics and accounts for relatively modest overall cost increases. Tariff news context. The report situates the findings within current trade policy developments that may affect the automotive sector. Alternative suppliers. Alternative suppliers across Europe, the UK and Asia obtained from the Deep Researcher are benchmark, showing viable diversification strategies. Impact assessment. The tariffs effects are categorized as low, moderate or high, offering a clear framework for interpretation. Recommendations. Several recommendations are given, including diversifying procurement using bonded warehouses and digital monitoring. In summary, the report progresses from component analysis to simulations, supplier options and recommendations, showing how data-driven modelling supports robust decision-making.